Flat Earth. The vector fails, part 2. So I was looking for an object and trying to explain what we're trying to explain about force and motion and all these kind of things and stuff like, and I found one. The arrow. So what I'm going to say about like what I'm trying to explain is, see, like we've got space station. I know this is like all falsified and you know what I mean, but how they depict it is a similar situation. So everything's weightless because they're in free fall, aren't they? You know what I mean? It's kind of like it's the same narrative as the environment that they're trying to say for this rising Earth aspect. Because really, right, the space station is supposed to be moving at like 17,000 mile an hour, 17,500. But so there's a force of motion there. You know what I mean? It's gonna like, how come everything doesn't stick to the back of the ship? Like everything should stick to the bottom of the Earth. You know what I mean? So in that same reference, it's showing you what I mean. Like things should just float, you know, in that kind of narrative. Because one sense, it's with the momentum of the space station or the Earth. You know what I mean? So if I let go of a ball, it'd just stay there. If I push the ball up, it'd carry on going. There'd be nothing to stop its momentum. So like, I've got a tennis ball. If I throw it up and it comes back down to my hand, it lost momentum and changed direction. They're calling the upward Earth to be the direction change, but what causes the loss of momentum? Say if I roll that tennis ball across a playground, you know, a massive tarmac area which is all smooth, then the air isn't going to cause enough friction to stop the ball for quite a long distance. You know what I mean? And stuff like, for example, like if I jumped out of a building, it's a bit morbid, but if I jump out, I've got that forward momentum jumping out of the building. You know what I mean? Right? So I go that way, but eventually, after a couple of meters, I suddenly start dropping, and all that forward momentum has disappeared. But if I roll a ball on the floor, it carries on going. So there's no air resistance to stop it in that kind of way. If I throw the ball out, it's going to suddenly start changing direction and it'll start going straight down. So like that, this idea of weightlessness is, it doesn't make sense because weight is necessary for these, for the explanation of what, you know, for why things go down and stuff, like, you know, things weigh differently. It's an important aspect of it, like gravity. For the heliocentric model, if we're going to talk about gravity, the amount of mass of Earth is massive, right? And they say it's like this super light gravity and stuff, right? So like, but then like, you know, you compare yourself to a massive boulder which is like way heavier than you, you know what I mean, like 10 times sizier or whatever. Then if it's such a light force, then why does that weigh so much more? Because really it's like the Earth's force plus my mass, you know, the Earth's mass plus my mass. It's like my mass is insignificant to Earth's. So it's like the Earth's mass is that it should crush me, really. So, you know, it don't work, does it? But but we still got a downward nature to things. So when I throw that ball, it's going to go down. You know what I mean? It can go across a little bit, but it's not going to go across like the distance it would make on if I roll it across a playground. You know what I mean? So projectile motion. So it's showing you like an arrow. You can't just aim it straight. You need to angle it up. So when it actually releases the bowstring, the arrow will aim toward the target where it's aiming. But another force will also act upon the arrow in a different direction. This force is the weight, and it will pull the arrow down towards Earth. The two forces combined will cause the arrow to move in a curved path. This type of motion is called projectile motion. I've got an example of it there. parabolic trajectories. I see, like, NASA kind of tells the truth. This is what happens with space rockets. They send them up and then they come back down. It's a parabolic path. It goes around the Earth. It goes here and here and here and all around, you know what I mean? It just doesn't go around it, because that part's a lie. You know what I mean? So I do think there's a lot of play on words when they're trying to tell you things and stuff like. So yeah, like the arrow, it should maintain its angle. It should not change its direction. So if I shot it up at 70 degrees, it should remain at a 70-degree angle and then come down and land. The flight should hit the floor before the tip. There should be nothing to change the angle of the arrow, because it's supposed to be weightless. You know what I mean? So this is proof of weight, you know? So it completely contradicts the upward rising Earth kind of aspect of things and stuff like. So another aspect of it, in a way. So the reason why things fall is because the Earth is rising up. It almost implies that they shouldn't be leaving a trail, because they should be just there. The sparks should be building up around them from the sparklers or whatever, and then the Earth would come up, you know. But I suppose this air drag, which is carrying the sparkly stuff and all that kind of thing, like. But still, you know, the speed that they go and all that kind of thing is quite a contradictory thing towards 22 mile an hour, because they're going well faster than that. And to top that off, we've also got Felix Baumgartner and Jordan agonizing 10-minute wait. Hang on, more time than when one was actually in the air before he received confirmation that he hit a top speed of 844 miles per hour, which is over 75 miles per hour faster than the speed of sound. So this, you know, if Felix Baumgartner were to fall that fast, there's another article that says 43.6 miles per hour, but you know, for that speed, right, then that must be how fast the Earth's rising. So Earth is rising faster than the speed of sound, which means, should you even be able to hear me if that's the case? You know what I mean? I don't know. But again, you know, it's more contradictory evidence towards the debate and stuff like. So I hope you enjoyed it, and thank you. Nice one, cheers.